Okay, so another way to represent a limit is like this. So we write fx, and it approaches L as x approaches A. So what this means, we can say fx approaches L as x approaches A. Alright. A bit about the definition of the limit. We are making x arbitrarily close to A, which also means that fx is arbitrarily close to L. So we are restricting x to be sufficiently close to A, x sufficiently close to A, but not equal to A. So x, in the case of limits, does not equal to A. So we're never touching A. Okay, so here are three examples. So the same line. Okay, this is the x-axis and the y-axis. Okay, so notice that here it is a filled circle at 1, at x equals 1. So we can write the limit as x approaches. What are we approaching? We're approaching 1 here. So as x approaches 1, fx, the equation for this line, is approaching 1. Okay. Another example is with a not filled center. Okay. So this is still 1. We are approaching 1. Yeah. And fx is still approaching 1. Even though we have a empty circle, it is still approaching 1. Okay. So, and the third example, which shows these two, is, look, here is 1, and here's a 2. Okay. So when x approaches 1 from the right hand side, okay, so when x approaches 1 from the right hand side, the line is still approaching 1, even though at x equal 1 the function is defined here. When we're using limits, we're still approaching here. It's the same for when x approaches the left-hand side. The left-hand side right here, it is still approaching 1, even though at x equal 1, the function is defined at 2 and not 1. Okay, we still have an empty circle here.